Hello. Today we are going to explore two learning strategies, case-based reasoning and problem-based learning. We're going to include a brief overview of these strategies and then focus in on some real-world examples of problem-based learning. Let's get started with case-based reasoning. Case-based reasoning operates on three key principles: analogical reasoning, experience-based learning, and cyclic process. Analogical reasoning is when you try to solve new problems by adapting solutions from past cases. Experience-based learning is when decisions are informed by what has worked or not worked before. The cyclic process in case-based reasoning follows a cycle of retrieving, reusing, revising, and retaining knowledge. The characteristics of case-based reasoning include knowledge reuse, incremental learning, and dynamic memory. This means learners create a storage for different cases over time that they can pull on as needed. Case-based reasoning's process can be summarized in 4 steps, and we've already talked about them: retrieve, reuse, revise, retain. When you retrieve, you find a past case similar to the current problem. When you reuse, you adapt that case and its problem to the solution. When you revise, you test and tweak that solution as needed until it fits what you're working on. And when you retain, you add that refined solution to your storage for future use. A unique feature of case-based reasoning is that there's a great focus on learning from experience. This can make it invaluable in all sorts of applications. Let's move on to problem-based learning, the focus of our real-world examples at the end of this video. Problem-based learning is learner-centered, which means students are in control of their learning process, guided by real-world, open-ended problems. Problem-based learning emphasizes collaboration, teamwork, and discussion. Some of its defining characteristics are authentic context, an inquiry-based approach, and scaffolded support. Students work in authentic contexts that mirror real-life challenges. They follow an inquiry-based approach to encourage exploration. And using scaffolded support means that guidance is slowly taken away until learners become more confident. Think of a child learning to ride their bike without training wheels. The process of problem-based learning includes problem presentation, analysis and hypothesis, research and inquiry, solution development, and reflection. Problem presentation introduces a challenging problem. Analysis and hypothesis identifies what learners already know and proposes initial solutions. Research and inquiry allow the learner to investigate the problem deeply. Solution development allows learners to collaborate with peers to create actionable solutions. And reflection allows the learner to reflect on what was learned and refine their process for future interactions. This method of problem-based learning creates an environment that supports critical thinking, problem-solving, and communication skills. You might be asking, how does this support learning? Case-based reasoning and problem-based learning support learning in their own ways. Case-based reasoning connects new problems to familiar contexts, enhancing memory and analytical skills, while problem-based learning promotes deep learning through active exploration and prepares learners for real-world scenarios. Together, they combine reflective learning with dynamic, inquiry-driven problem-solving. Let's move on to our real-world applications. Our first example is in a high school English classroom. Students analyze a novel like The Great Gatsby and propose a modern adaptation addressing social issues. Some benefits of this activity are encouraging creativity, critical thinking, collaboration, while some challenges would be balancing creativity with analysis and even accommodating varied reading levels. Our next example is an online German class where students are supposed to be designing a travel guide for a German-speaking city. Some benefits would include promoting language use, cultural immersion, and even digital skills, while some challenges would be technical barriers, varying proficiency levels, and even motivation in online settings. Our final example is training for instructional designers. Trainees are supposed to create a prototype learning module addressing a real-world training need. The benefit would be that it's a practical application, it might require collaboration, and it definitely requires professional relevance. But a challenge would include access to resources, applying the theory, and effective feedback. Both case-based reasoning and problem-based learning offer engaging, impactful learning experiences that prepare learners for real-world challenges. Thank you for watching. Have a good one.